Hello everyone. In this video, we're going to look at how we can find out the equation of a line. A key inquiry question. How can I represent and interpret direct relationship between two variables? Answers to last lesson's work is in slide 3, slide 4, and slide 5 for your reference, and also slide 6. The 5 for 5 starter is in slide 5. Please attend them on a piece of paper or in your exercise book. Once completed, you can check the answers, which are in slide 8. The primary focus of this lesson is finding the gradient of a line. What is gradient of a line? Here you have a mountain and a hill. A gradient is a number that describes how steep a line is. Basically, it's the steepness of the line. I'm going to have square grids on the background to identify the steepness of the line or gradient. This mountain, it's 4 up and 4 across. For this hill, it's 2 up and 4 across. And those are the movements will take you from one end of the line to the other end of the line. So the mountain is twice as steep as the hill because it's 4 across, it's 4 up, whereas the hill is 2 up for every 4 squares across. Now let's see how we can calculate the gradient. The formula is change in y over x, change in x. And this formula, rise over run, really helps us to identify the gradient. It's the rise. So from one point to another point, we're rising by 5. We are running 5 across. So it's 5 divided by 5, which equals 1. Let's try another example. Now again, it's rise over run. From one point, we are rising by 6 squares, divided by run. Well done for those who already worked out. Divided by 3. So you're running 3 squares across 6 divided by 3, which equals 2. Using this as an example, please try the examples in slide 13 and slide 14, and then check your answers. Now let's look at another example. Notice that the line from left to right, it's going down. We use the same formula, rise, and rather than increasing, we are decreasing. So we're going down 4 squares, hence it's minus 4, and across, which is running, is 1, which would be minus 4 over 1, which is minus 4. The gradient is always left to right. The gradient is left to right. Using the previous example, can you please attempt this question? Here are the answers. Now notice we didn't go from one end of the line to the other end of the line. Let's see the reason why that's the case. Now you can see one point in the corner of the square. However, the other point is in the middle. We're not sure whether it's exactly in the middle. So we're choosing a triangle to identify the steepness, and the triangle is chosen corner of the square to another corner or vertex. So here in this case, a triangle is sketched from 5 to 1. It's 4 squares down, which is minus 4 divided by 2. We could draw any triangle. Let's just say I construct another triangle here. I would have gone down 2, so it's just minus 2 over the run would be 1 square. Minus 2 divided by 1 gives us minus 2. Also, minus 4 divided by 2 gives us minus 2. Hence, it doesn't matter how long is that triangle because the gradient is the same throughout the line. We've seen how to calculate the gradient of the line. Now let's see how we can find out the y-intercept. Using the gradient and y-intercept, we can construct the equation of a line. Y-intercept is where the line crosses the y-axis. For example, if you take a line A, it crosses the y-axis at 6. So the y-intercept for A is 6. If you take a line B, it crosses the y-axis at 2. There is misconception where some students look where they cross the x-axis. Remember, it's not the x-axis, it's the y-axis. Let's go through one more. For equation or the line C, it cuts through the y-axis at 0. Now, can you find out the y-intercept for the other lines D, E, and F? And also, can you work out whether it has a positive or a negative gradient? The answers are in slide 21 for your reference. Once we calculate the gradient and the y-intercept, we can create the final formula. The formula is y equal to mx plus c, where m is the gradient, which we found out in the first part of the video, and c is the y-intercept. Now let's construct the equation of this line. We construct a triangle. Notice, as I mentioned earlier, doesn't matter how big the triangle is, it would still give us the same gradient as the gradient is the same throughout. In this case, it's 2 over 1, rise over run, and the y-intercept cuts at positive 1. So the equation is y equal to, instead of m, the gradient, which is 2x plus, instead of y-intercept, we write 1. Let's go through another one example. Now I construct a triangle. It's rise over run, 3 divided by 1, which gives us 3 is the gradient. The y-intercept cuts at positive 2. So the equation is y equal to 3x plus 2. Using this as an example, please try the example in slide 26 and 27.